You are sitting in a restaurant. A plate arrives with cold slices of tuna resting on rice. You pick one up, dip it in soy sauce, and eat it without thinking twice. Raw fish feels normal. Now imagine the waiter returning with raw chicken. No seasoning, no heat, no pan. Just a cold pink piece of chicken on a plate. Suddenly your stomach turns. Raw chicken feels dangerous in a way sushi does not. Raw pork sounds worse. Raw hamburger comes with warnings. Even raw beef dishes, like steak tartare, are treated with a level of caution that a piece of salmon sashimi often seems to escape. So why can you eat raw fish but not raw chicken? The first answer is that the question is slightly misleading. You can eat raw fish, but that does not mean it is automatically safe. And raw chicken is not guaranteed to make every person sick every time. But it is risky enough that cooking it is the normal and sensible rule. The real difference is not simply fish versus meat. It is the kind of danger involved. It is parasites, bacteria, viruses, toxins, temperature, handling, and what happened to the food long before it ever reached your plate. Sushi is not safe because fish has some magical immunity to germs. Sushi becomes less risky when the entire path from ocean to restaurant is designed around the fact that someone may eat it raw. The species matters. The supplier matters. The temperature matters. The handling matters. And for many fish, freezing matters. Start with the danger people think about first. Parasites. Fish can carry parasites. One of the best known is anisakis, a small worm that can infect certain marine fish and squid. If a person eats an infected fish raw or undercooked, the parasite can attach to the stomach or intestine. That can lead to stomach pain, nausea, vomiting, and in some cases medical treatment to remove the worm. It is not a myth. It is not an internet scare story. And it is one reason raw fish needs special handling. Freezing can kill many parasites that matter in seafood safety. That is why freezing is a major control step for many fish served raw, marinated, or only partly cooked. But here is where people get confused. Freezing is not a magic button. It does not turn every piece of seafood into safe sushi. It does not kill every harmful bacterium. It does not remove viruses. It does not erase contamination from dirty water. It does not repair fish that was badly handled after being caught. And it does not destroy every toxin that may already be present. It solves one important problem: parasites, that is all. Some fish sold for raw preparation may be exempt from freezing requirements because they are considered low risk for parasites under specific conditions. Some farmed fish can also have lower parasite risks when their feed and environment are tightly controlled. But lower risk is not zero risk. That is the rule people forget. A frozen fish may be safer from parasites than an unfrozen fish. It is not automatically safe from everything else. Raw oysters are a perfect example. They are seafood. They are cold. They may be served in respected restaurants. They may look fresh, clean, and expensive. But raw shellfish can carry bacteria and viruses from the water where they lived. A perfectly beautiful oyster can still make someone seriously ill. So sushi is not safe because the ocean is clean. The ocean is full of life. And some of that life can make humans sick. Then there is another seafood danger most people never think about: toxins created when certain fish are not kept cold enough after being caught. Some fish, including tuna and mackerel, can develop high levels of histamine when spoilage begins. That can cause a type of food poisoning sometimes called scombroid poisoning. And unlike a parasite, histamine is not reliably destroyed by cooking. It is not reliably destroyed by freezing after the fact. It is not reliably destroyed by smoking, curing, or canning. That means a fish can be cooked and still be unsafe if it was mishandled earlier. This is why fish preparation is not only about whether it is raw. It is about the entire cold chain. Was the fish chilled quickly? Was it kept cold? Was it transported properly? Was it stored properly? Was it handled cleanly? You cannot see most of those answers on the plate, but they can matter more than the color of the fish or how fresh it smells. Now compare that with chicken. Chicken has a different problem. The biggest concern is usually not a visible parasite in the muscle. It is bacteria. Two names appear again and again: Salmonella and Campylobacter. These bacteria can live in poultry and contaminate meat during processing. The chicken can look normal. It can smell normal. It can be freshly packaged. And it can still carry bacteria that cause serious illness. Campylobacter is one of the most common causes of bacterial diarrheal illness in the United States. Public health agencies estimate it causes about 1.5 million illnesses in the country each year. Raw or undercooked poultry is the most common source, and the danger is not limited to eating the chicken itself. A tiny amount of raw chicken juice can spread bacteria onto your hands, your knife, your cutting board, a salad, a countertop, or food that will never be cooked. That is why chicken can be so risky in an ordinary kitchen. The chicken does not need to look spoiled. Pathogens often do not announce themselves with a bad smell, strange color, or obvious slime. Your eyes can tell you whether food looks rotten. They cannot reliably tell you whether it contains salmonella. This is also why washing raw chicken does not solve the problem. Water can splash contaminated droplets around the kitchen, moving bacteria farther than they were before. Chicken needs careful handling because the danger can spread. And cooking is the most reliable way to destroy the pathogens that concern us. But why does raw tuna feel less frightening? Part of the answer is cultural. Sushi has become familiar. It is served neatly on a plate. It arrives looking finished. It is associated with skill, precision, restaurants, and careful preparation. Raw chicken arrives looking unfinished. It belongs to the part of cooking most people never want to think about: cutting boards, packaging, cleanup, and cross-contamination. But culture is not the whole answer. The risks are truly different. Poultry is widely associated with bacteria that can infect humans. Fish can also carry bacteria, but raw fish has a more obvious parasite control strategy: freezing. That does not make it harmless, but it gives the seafood industry a specific tool for reducing a major danger. Raw poultry has no equivalent shortcut. Freezing chicken does not reliably kill all the bacteria that matter. A lemon does not solve it. Salt does not solve it. A quick rinse does not solve it. Cooking does. Now let us talk about raw beef, because this is where the rules become more complicated. People eat steak tartare in France, carpaccio in Italy, yuko in Korea, kibanaya in parts of the Middle East. Raw or lightly cooked beef dishes exist in many food traditions. That does not mean raw beef is risk-free. It means people developed specific ways to select, prepare, season, and serve it. And even then, there's a major difference between a steak and a hamburger. With an intact steak, bacteria are more likely to be on the outer surface than deep in the center. That is one reason a steak can be seared on the outside while remaining rare inside. But grinding changes the situation. If bacteria are present on the surface before grinding, grinding can mix them throughout the meat. That means a rare burger and a rare steak are not the same safety question. A burger is not just a steak in a different shape. It is a food where the surface has been distributed through the middle. Pork has another history. For generations, raw or undercooked pork was feared because of trichinella, a parasite that causes trichinellosis. Modern commercial pork systems have greatly reduced this risk in many places through changes in animal feed, production practices, and inspection. But reduced risk is not no risk. Raw or undercooked pork can still carry foodborne hazards. Wild game, including wild boar and bear, can be especially risky for parasites. Again, the real rule is not this animal is safe or that animal is unsafe. The real rule is that every food has a different set of threats. Raw seafood can mean parasites. It can mean bacteria. It can mean viruses. It can mean toxins. Raw poultry can mean Salmonella and Campylobacter. Raw ground beef can mean bacteria mixed throughout the food. Raw pork and wild game can mean parasites and bacteria. Shellfish can mean pathogens from the water. The danger changes with the animal, the environment, the processing, and the preparation. Ceviche makes this even more confusing. When fish sits in lime or lemon juice, the acid changes its texture. The flesh becomes firmer and more opaque. It can look cooked, but it is not truly cooked. Heat works in a predictable way to kill many pathogens and parasites. Citrus does not provide the same guarantee. Ceviche can be delicious. It can be traditional. It can be prepared carefully by people who understand seafood. But acid is not a replacement for sourcing and parasite control. The fish still needs to come from a safe supply chain. The same is true for smoked fish, cured fish, and marinated fish. They may look transformed. They may taste transformed. But food safety is not just about how food looks. It is about what invisible risks remain. And that brings us to the most honest answer. You do not eat raw fish because raw fish is inherently safe. You eat raw fish when the risks have been managed well enough to make it an informed choice. You avoid raw chicken because the bacteria associated with it are common, difficult to detect, easy to spread, and reliably destroyed by cooking. The line is not between fish and meat. The line is between food that has been carefully selected and handled for raw consumption and food that has not. Even then, raw food is never completely free of risk. For pregnant people, children, older adults, and people with weakened immune systems, official food safety guidance is especially cautious. Raw or undercooked seafood, meat, poultry, and shellfish can pose greater dangers for them. So the next time you eat sushi, do not think, raw fish is harmless. Think about the invisible work behind it. The supplier, the storage, the freezing, the hygiene, the timing, the species, and the fact that risk was reduced, not erased. Raw chicken scares us for a reason, but sushi deserves respect too, because the true difference is not fish versus meat, it is preparation versus assumption. Which raw food would you trust most? Sushi, ceviche, oysters, or steak tartare? Leave your answer in the comments and subscribe to Andy for more strange science behind the food you eat every day.